This is the second video on chain rule, and I know I'm going to need more room. So before I start, I'll just move my problem F to a separate sheet of paper. Okay, because I just write so big. And I'll put a little sticky over it so that I can write over this, okay? This way I have the entire page dedicated to my problem E. Okay, what are we doing here? So we're using the chain rule to differentiate this function f of x. The big picture is a fraction or something getting raised to the negative third power. So what is f prime of x? First of all, bring down that exponent of negative 3 to the front. Keep everything the same inside. But the new exponent is now negative 4. But don't forget, you need to multiply this by the derivative of the inside function. What is the inside function? Is that fraction 3x minus 1 over 2x plus 5. So, it's very similar to the last problem we did. We're going to have to spend some time simplifying this red piece. Okay, so all my time and page and room will be used to do that red underlined quotient rule piece. Okay, so let's do the quotient rule. Quotient rule. I have my f to be 3x minus 1, which means f prime is just 3. G is 2x plus 5, which means g prime is 2. Quotient rule says do g squared in the bottom and do gf prime minus fg prime on top. So let's put these pieces together to find the derivative of this inside function. Okay, big fraction bar. In the denominator, I will have 2x plus 5 squared. On the numerator, I need 2x plus 5 times 3 minus 3x minus 1 times 2. All right, let's distribute and simplify. I will get 6x plus 15, but I'm going to be very careful and multiply by 2, not just 2, but negative 2. So I will get minus 6x, and then negative times negative is positive, so I will get plus 2, and the denominator remains the same. And when I'm simplifying these like terms on the numerator, oh, look at that. This 6x will cancel out with this negative 6x, leaving us with the only numerator of 17 and 2x plus 5 squared. So an embedded quotient rule that we have to solve. But now I'm going back. What I just found out is that red underlined piece. So if I may copy this entire work, give me 1 second. If I duplicate this, bring this down, okay? And what I'm going to do is I'm going to replace this with what we just found, okay? Duplicate this. All right. So all we need to do is simplify this and we will be done, okay? Of course, I need another page. All right, let me add another page. So when I'm simplifying this, I have f prime of x equals, I'll use the same format. But here's the thing though, I have a negative exponent. So, you know, when you have a negative exponent, you have to reciprocate it, right? To convert it into a positive exponent. So take a look at this for me, okay? The negative 3 is still on top of the fraction. But I'm going to actually write down 2x plus 5 on top of the fraction with the positive 4 as its exponent. It was in the bottom, but I brought it to the top because it was getting raised to the negative 4th power. Now the 3x minus 1 was on top, but I'm going to send it to the bottom with a positive exponent of 4. And I'm going to multiply this with 17 over 2x plus 5 squared. Okay, what can we do? I'm going to group something for you. Can you see that we have 2x plus 5 raised to the 4th power over 2x plus 5 raised to the 2nd power? That's the same, but top has 2 more, right? Exponent of 4 means it has 2 more of these compared to the bottom. So you know when I simplify this, I can multiply the numbers. So let me do 3 times 17 first. 3 times 17 is negative 51. Negative 51. But that circled parenthesis, I will have 2x plus 5, but raised to the second power. Okay? Why do I have that? Because I did 4 minus 2, and because top had 2 more, that's what remains. I'm not going to have any more 2x plus 5 in the bottom of the fraction. So the only thing that's left in the bottom of the fraction is 3x minus 1 raised to the 4th power. So I think they're so cute, like the way that we had to simplify them. So, you know, you review your algebra skill, kind of things that you learned long time ago. But to make our calculus problem answers pretty, we had to kind of remember them, right? So that was one example, okay? It was a chain rule problem, but what took more time was the, what's it called? The quotient rule, right? See, this is why I want to avoid quotient rule all the time. But you know, I think it's good practice that we do them, okay? I think we've been doing it for a while. All right, how about one more? One more, which is, oh, another one, another quotient. Would you like to see how I avoid quotient rule? Or do you want to do quotient rule? I'm going to avoid quotient rule this time, okay? I don't know how this will go, but I will rewrite this. I will rewrite this. Take a look. I can rewrite this as x squared times 1 plus x to the what power? Negative 5th power. This is me being creative because I did 2 problems on quotient rule and I just don't want to do them again. So I rewrote the function as x squared times 1 plus x raised to the negative 5th power. Instead of quotient rule, guess what rule I must use this time? The product rule, right? Now we clearly see a product of x squared times this red chunk. So let's do the product rule this time. Product rule, which says first times the derivative of the second plus second times the derivative of the first. I'm going to identify all my pieces. First is x squared. Derivative of that is 2x. Second is 1 plus x getting raised to the negative 5th power. And we have to use a chain rule to find the derivative of that. So take a look. What is g prime? G prime, bring down that negative 5 to the front. Keep everything the same inside the parenthesis, but the new exponent is now negative 6. But technically, you need to multiply this by the derivative of the inside part, which is 1 plus x. I guess we're lucky because this derivative of 1 plus x is simply just 1. So you know how sometimes people make a mistake, but they still get the right answer? That could have happened. Even if you forgot to multiply by the derivative of the inside function, you would have been okay. Why? Because the derivative of the inside function just comes out to be 1. So multiplying by 1 doesn't really change anything. So I'll say g prime is simply negative 5 times 1 plus x raised to the negative 6 power. So I got all my pieces written down super big. Maybe I should make it a little bit smaller. And I am ready to do the product rule. So the product rule says first times the derivative of the second. First is x squared. Derivative of the second is this. So let me write that. That is negative 5 times 1 plus x to the negative 6 power plus, let's move on to the next part, g times. The g is 1 plus x to the negative 5. We multiply this by f prime, first derivative, which is 2x. Now we wrote down the derivative. Now what we have to do is just to simplify this to make it a little bit prettier, okay? All right, what can we do? I can make the first fraction to be negative 5x squared divided by 1 plus x to the 6th power. I can make the second one to be 2x on top. Because 2x's exponent was positive 1, that's going to remain on top. But what goes to the bottom? 1 plus x to the positive 5th power. This is an answer, but how about we put them together in a single fraction? Because denominators are very, very close. You notice they both have the base of 1 plus x, but this one has one more, right? 1 plus x to the 6th power, while this one has 1 plus x to the 5th power. So what I will do is I will multiply the top and bottom of my second fraction by one more 1 plus x. So that way, the first one remains the same for right now. But the second one, if I may distribute, to get 2x plus 2x squared, the denominator now is 1 plus x raised to the 6th power because we just multiplied one more. 5 plus 1 will give us 6 there. Alrighty, how about I add another page to put these two fractions together? So the numerator will be these two put together. So let's see if we can simplify some like terms. I see there is negative 5x squared and there is positive 2x squared. They will combine and give us negative 3x squared. And let me write down that plus 2x. And that denominator just once. So this is it. This is the derivative of this function. It took us a while. But if you want to avoid quotient rule, you can rewrite using a negative exponent and go with the product rule. I think the work is about the same, but product rule, less people make mistake because, addition can be commutative, while if you screw up on the order of the quotient rule on the numerator, then the answer will have an opposite sign. So that was a slightly different problem. I think what made this a little bit more tedious was the algebra part, simplifying and things like that. But I hope you guys got the big idea of the chain rule and how the product rule was necessary to find the derivative of this. Actually, you know what? The big picture was product rule, right? And then when we were doing this product rule, we had to do a quotient rule to find, the chain rule to find the derivative of the second. I've been talking for so long, so I'm going to take a quick break and I'll come back and show you how to do example 2 and 3 and a couple more in another video.